Underground mining tunnels below the Giza plateau. It's one of those things that it just seems like some sort of fantasy. You know, you hear all this mythology about underground tunnels and secret structures hidden below the Giza plateau. Well, it is real. Well, look at this too. There's a channel here leading into this, kind of a channel flowing through here. That's crazy. I'll just get one more shot back here before we go.
All right, everyone, welcome back to the land of Chem. I'm your host and the author. My name is Jeffrey Drum. Thank you all so much for joining me again.
All right, everyone, welcome back. And in today's Sunday site visit, I will be proposing an explanation for the 1 kilometer deep shafts that were recently discovered by the Synthetic Aperture Radar Technology team, COFRA project, and presenting some exclusive footage of some underground components across the Giza Plateau. Ladies and gentlemen, as always, thank you all so much for the support. I think that is it for today's intro, so without further ado, let's get right to it. All right, everyone, here we go with tonight's episode. Now, to begin, after the recent announcement by the Synthetic Aperture Radar Technology team, COFRA project, revealing what they call, quote, the discovery of a huge city under the pyramids, end quote, my mind has been racing and there is so much more to discuss. So if you're new to the channel, usually on Sundays, I present exclusive footage from our on-site expeditions to investigate ancient structures across the world. But I have so much more research to present, so today will be a hybrid of site footage and part 2, following up on the information from episode 149, revealing the official statement by team member Armando Maeve. And I will quote here that during the press conference, the structures corresponding to the mythical halls of Amenti will be unveiled for the first time. Key discoveries to be presented include the identification of structures, chambers, and corridors located within the Pyramid of Khafra, the identification of extensive series of vertical shafts estimated to extend to depths of at least 1 kilometer, with each major pyramid serving as an access point to these underground systems, the discovery of vast subterranean chambers with the dimensions comparable to those of the pyramids themselves, and stating here a remarkably high correlation between the layout and characteristics of these underground chambers and the legendary halls of Amenti described in ancient myths such as those involving the god Thoth. End quote. Now, let me read that one more time, specifically this part here. The identification of an extensive series of vertical shafts estimated to extend to depths of at least 1 kilometer, with each major pyramid serving as an access point to these underground systems. This is a discovery of immense proportions. So now, let's take a look at some footage. From Sunday Site Visit 50, the underground mining tunnels below Giza, known as the Tomb of the Birds, so you can evaluate the features of the Giza underworld that is permeated with metal mineral saturated tunnel systems. Let's go.
And ladies and gentlemen, this is it. This is the entrance into the subterranean underworld below the Giza plateau, known as the Tomb of the Birds. And I will say, it stinks in here. because this is a bat cave. But I can tell you the smell in here has absolutely nothing, no similarity whatsoever to the smell of ammonia inside of the Red Pyramid. It smells like what you would expect a rodent to smell like in here. But inside of the Red Pyramid, it is pure chemical ammonia. And back there, ladies and gentlemen, these are the entrances into the tunnels. Look at that red iron oxide material. And it looks like those stones were put over there to block that entrance. In the entrance of safety, I mean, we're not crawling through any tunnels back here because I've already showed documentation of what's back there, and we certainly don't have the gear for that. But this cave system does exist. Trying to be extremely careful. Holy shit. Look at that. It exists, ladies and gentlemen. Looks like possibly leading in the other direction as well. All right. So I will say that we've been quite fortunate on today's expedition. Look at all that iron oxide. Holy shit. Underground mining tunnels below the Giza plateau. It's one of those things that it just seems like some sort of fantasy. You know, you hear all this mythology about underground tunnels and secret structures hidden below the Giza plateau. Well, it is real. Well, look at this too. There's a channel here leading into this, kind of a channel flowing through here. That's crazy. I'll just get one more shot back here before we go.
All right, now on to these 1 kilometer deep shafts. And here you can see the above ground pyramids of the Giza Plateau. And we're going to do a little exercise on perspective. So the Great Pyramid was originally approximately 150 meters tall. And I'm going to show you what a 1 kilometer deep shaft looks like in comparison. So up here we have the pyramids. Here is the ground level. And in red, I have indicated our 150-meter height of the Great Pyramid. Now, if you multiply this by 7, you will be 1,050 meters below the Giza Plateau. This is the depth proposed by the Khafra project team as revealed by their synthetic aperture radar Doppler tomography technology. Absolutely staggering. And they also claim that each major pyramid serves as an access point to these underground systems, so we may be looking at something like this, with chambers of dimensions comparable to those of the pyramids themselves, end quote. With this diagram being relatively to scale for demonstration purposes. Now, at this point, I will say that the decision of the team to describe this system as a quote-unquote huge city, end quote, and apply the nomenclature of the quote halls of Amenti, end quote, is a huge mistake that is going to further discredit this already controversial research. I propose that what they are about to reveal is twofold. First, what I will refer to as the causeway, subsurface, metal ore mining, and industrial chemical manufacturing, extraction, and distribution infrastructure network. And second, the deep bedrock, hydrothermal vent system, natural formations that are a part of the Giza Plateau ancient seafloor. And yes, the Giza Plateau bedrock used to be the bottom of an ancient sea.
All right, everyone. I hope you're enjoying the video. And please remember to subscribe for more content if you're interested in the technology of ancient civilizations utilizing physics and chemistry and the function of the Egyptian pyramids and other ancient structures from around the world. If you want to help support the channel, you can pick up a copy of the Land of Chem book and grab some merch at thelandofchem.com and for access to exclusive content. Subscribe to the members-only channel now with 19 massive research episodes revealing some of my most groundbreaking discoveries thus far. Links to everything in the video description below. Thank you all so much for the support. Now, back to the video.
And I will quote from this article here. Travels in Geology, the Pyramids of Giza, Wonders of an Ancient World. Stating here, the Giza Plateau, whose flat surface rises more than 100 meters above sea level, is an extension of the country's vast western desert. The bulk of the plateau is composed of stacked carbonate layers deposited from the late Cretaceous through the Eocene on the floor of the Tethys Sea. This long and narrow ocean separated Africa from Asia following the breakup of the supercontinent Pangaea, which began about 200 million years ago. The remnants of this ancient ocean make up the modern Mediterranean Sea. Khufu and his successors had the pyramids built atop the Mokattam Formation, a series of relatively hard Middle Eocene limestone and dolomite layers that form the surface of this part of the plateau. Many of the blocks that compose the Great Pyramid appear to have come from the same formation, excavated in a quarry a short distance south of the structure. The Mokattam breaks cleanly along bedding layers and is riddled with many vertical joints, so the rock was ideal for dividing into blocks, even with simple hand tools available to the ancient Egyptian masons. The scale of the construction is mind-boggling. The Great Pyramid itself alone consists of an estimated 2.3 million blocks, averaging 2.5 tons apiece. The majority of these consist of nummulitic limestone, which contains numerous fossil shells from especially large single-celled marine foraminifera of the genus Nummulites. As you walk around the Great Pyramid's base, you can clearly see in many of the blocks the round and oblong shells from these creatures which thrived in the Tethys Sea some 50 million years ago. So now here are some images of the Tethys Sea, with most of what we know as Egypt today being completely underwater millions of years ago. And I am proposing that these kilometer-deep shafts below the pyramids are actually the remains of extremely ancient hydrothermal vents that were originally a part of this ancient sea floor. And I will quote here that hydrothermal vents typically do not go very deep into the Earth's crust, usually only penetrating a few kilometers down through cracks and fissures in the ocean crust where seawater can reach the hot magma below, allowing the heated water to then rise back up on the seafloor through the vent opening. And it is these vents that penetrate a few kilometers down into the bedrock is exactly what the team is describing in the deep bedrock of the Giza Plateau. And these hydrothermal vent systems also explain another mysterious feature of the Giza Plateau bedrock that has been extensively investigated here on the channel: the iron and metal ore mineral deposits. And remember, from episode 131, I presented chemical analysis data from these iron veins revealing silicate microspheres, which are from fulgurites. Fulgurites, otherwise known as fossilized lightning, direct evidence of high voltage electric current flowing through these metal ore veins that corroborates my hypothesis as presented in episode 106 regarding lightning as the power source of the Egyptian pyramids. Of course, this lightning also operating in conjunction with telluric currents as a self-sustaining reciprocal power source. And in episode 131, I presented the following article from geologist Dr. Robert Schoch, the only other researcher other than myself who has ever even bothered to pay attention to these absolutely critical features of the Giza Plateau, where he presents his hypothesis that these iron veins are Lichtenberg figures from massive plasma discharges resulting from a solar flare. And I'll quote here, he states that the Giza Plateau is one location where plasma from this solar event touched ground level. The pyramids were built on and to mark the center or focal points of major plasma strikes where, quote, the sun touched the earth, end quote. Now, I disagree with the proposal, as the chemical analysis data has proven that these are not Lichtenberg scarring patterns, but rather naturally occurring iron and metal ore mineral deposits. And in his article, he actually presents this as a possibility. And I will quote here, lightning versus hydrothermal mineralization, stating one critic of his hypothesis regarding the plasma discharge has suggested that all we are looking at are intrusive, iron-rich hydrothermal deposits, which are often found in limestone and other sedimentary deposits. Briefly, I would point out that one does not preclude the other. That is, in my assessment, both can and do occur on the Giza Plateau. One can observe iron-rich layers in cross sections of the limestone. In any specific case, one must address the possible causative agents and the possible source of heat, not simply to assume everything represents, quote, classic hydrothermal features. We should consider various possibilities regarding the source of heat, causing the formation of superficial features that flow like Lichtenberg patterns on the surface that just happen to emanate from the two pyramids. What is the source of the heat? Did it come from below, for instance, magma in prehistoric times, or from above, for instance, lightning or plasma discharges at the end of the last ice age? The ancient dynastic Egyptians acknowledged and recognized ancient lightning strikes, thunderbolts on the Giza Plateau. Perhaps they understood what had happened at Giza, end quote. So, in these iron veins, we have direct evidence of the extremely ancient, millions of years old, hydrothermal processes on the Giza Plateau seafloor that created not only these hydrothermal vents extending kilometers down into the bedrock, but also formed these iron and metal ore mineral deposits. And these veins that stretch across the Giza Plateau, as described here regarding the types of hydrothermal deposits, these vein deposits, these are mineral deposits that occur in fissures or cracks in rocks. They are formed when hydrothermal fluids circulate through the rocks and deposit minerals in the cracks. vein deposits are rich in metals such as gold, silver, copper, and lead. And here, regarding replacement deposits, these deposits are formed when hydrothermal fluids replace the minerals in the rocks they come in contact with. Replacement deposits are often associated with limestone or other carbonate rocks and can contain lead, zinc, and copper. Now, the chemical analysis data that I have presented here on the channel reveals all of the metals that were just mentioned. The Giza plateau was once an ancient sea floor that featured a variety of hydrothermal geological processes that created the plateau bedrock itself. And when the Tethys Sea receded, we were left with these 1 kilometer deep shafts, the remnants of these hydrothermal vent systems, and a system of mineral ore permeated caves, cavities, tunnels, and shafts embedded within the plateau limestone bedrock. So as I stated in episode 149, I predict that the scan data that will be revealed on March 15th in an international press conference in Italy will present two main features. As I mentioned first, the causeway, subsurface, metal ore mining, and industrial chemical manufacturing, extraction, and distribution infrastructure network running just below the surface on the east side of the three pyramids, an industrial infrastructure system that may look something like this. So now let's go back to the first diagram. With the 1 kilometer deep bedrock shafts, which I have now proposed are actually natural features of the ancient Tethys seafloor hydrothermal vents. And now, here we have the three pyramids, the causeway in blue, and the Sphinx over here, and our measurement of the Great Pyramid here. And all of this relatively to scale for demonstration purposes. We know that there are subsurface features along the causeway, such as the Osiris shaft and the network of deep vertical pits that extend approximately 33 meters down. So I'm going to use this smaller measurement here just to be generous about the depth of these subsurface features along the causeway. So what I am proposing here in this diagram is the subsurface, maybe 50 to 100 meters deep maximum, that runs alongside the causeway down toward the Sphinx enclosure area. This is the metal ore mining, processing, and industrial chemical extraction and distribution system that supports the above ground pyramid manufacturing reactors. So now I'll put in some footage so you can see these pits adjacent to the causeway and just how deep they descend down into the bedrock.
Several more of these openings leading into the bedrock below the causeway. There's one here, there's one here, which look very similar to the opening of the Osiris shaft, which I'll show you in just a moment. So there's certainly potential for similar structures that still exist below the Giza plateau. Again, this one is of particular interest. This little injection hole, and man, that thing is just completely eroded. So clearly there was something here within the structure that once existed around this thing that fed down into this hole. And to show you, okay, there in the distance, the final pyramid, this shaft. And we'll walk right over here to the opening of the Osiris shaft. But you saw these other two shaft openings. Maybe, I don't know, 30 meters away. There's another one. Okay, so this one also has this vertical feature going down in this direction. This one certainly looks a lot more square than the other ones. I can clearly see that it goes down in this direction and then off in this direction. Okay, so now we're looking at shafts that connect into the southern portion of the Giza plateau system. And that is one of the reasons for the delineation of north of the causeway and south of the causeway, because there's a system that moves down in this direction and a system that goes in this direction. All right, so this is the Osiris shaft here, and the opening is right here. Boom. Okay, you can see the location in relation to the Great Pyramid and the Central Pyramid. So what we're going to look at today is the other side. So there's a passage that goes underneath the causeway here that opens on the north and south side of the causeway. All right, so now this was the first shaft that I just showed, and this is the northern opening of the Osiris shaft. And if you look at pictures from 10 years ago, this sand was all removed from here. There was no concrete barrier that had been added. These are all recent additions. You also notice that this opening is fairly weathered and eroded. Yes, I know the trash is unfortunate. And this is just where it accumulates, is it? Makes its way. Ma fish camel, shukran. As it makes its way down the Giza plateau. And the Osiris shaft is a critical component to this entire system, and the ultimate goal of the processing complex that was constructed here on the Giza plateau, because it's not just about producing the chemicals. All right, we have the causeway here, and then more of these shafts. Getting down to the bedrock. These are much smaller. and not nearly as eroded. But I can still very clearly see that it opens up down here in this direction and down in this direction, possibly even this direction, back up toward the Great Pyramid. Now, in my opinion, these shafts are not necessarily compatible with the antiquity that I sense from the larger, more eroded shafts. Again, you can see this vertical component here. There's a vertical component. All right, so I'm about to reveal another huge detail that I haven't discussed yet. All right, so the shafts closer to the pyramids are highly eroded. These distribution shafts, whoa, I mean, that thing is deep. Okay, the upper shafts, highly eroded. The lower shafts displaying significantly less erosion. So remember, at some point in this process, you got to neutralize your solution. And that may be an indication of what we're looking at here, that by the time we've reached this section of the Giza Plateau, the acidic solution has been neutralized. Yeah, I mean, these are just absolutely cavernous. And I don't know if you can hear the echo of my voice as it goes down into this shaft, but I mean, these things have to be deeper than the Osiris shaft for sure. The Osiris shaft is about 100 feet. I mean, I can't even estimate the depth of that because I can't see the bottom, but it's got to be at least twice that depth. Okay, here's another one that has the same injection port system. You can see here, there's an injection hole. Adjacent to this huge pit. A very similar configuration to the one that we saw on the south side, where there was a port, injection port here, that leads down into the much larger pit. I'll show you the opening of that. Is here, which is also highly eroded. And I'm not a huge fan of standing super close to this thing because there's hopefully you can see that hole here. So the port is here, flowing down into the pit. Okay. All of these things are interconnected, flowing down the northern side of the Central Pyramid Causeway. And look what we have here, the head of the Sphinx. And now essentially we're back to where we started today's Sunday site visit expedition, at the Sphinx enclosure. ما فيش كامل. شكرا صديق. Another one here. And now we've reached the termination of that shaft distribution system here into the Sphinx enclosure. Okay, so these, I'm standing right on top of it now. So at the beginning of the episode, I showed this patchwork and modern thing here. This area directly below me is the one with the metal door. There's another one of these openings right here. Okay. This one, I believe, goes in this direction. The rest of these terminations come directly from the Central Pyramid.
All right, now, here we have the two systems on the same diagram. The causeway, subsurface metal ore mining and industrial chemical manufacturing, extraction and distribution infrastructure network. And second, the deep bedrock hydrothermal vent system, natural formations that are a part of the Giza Plateau ancient seafloor. And I am predicting that the scans will reveal a variety of connecting hydrothermal vent tubes and a network of caves, cavities, and other natural formations within the bedrock that the synthetic aperture radar CAFRA project team is now describing as a, quote, huge city, end quote. This is not a city, and it is not the halls of Amenti. These are natural features of the ancient hydrothermal geological processes that form the bedrock seafloor of the Tethys Sea that is now the Giza Plateau. And I propose that this network is not only permeated with metal minerals, just like what you saw in the Tomb of the Birds, which is actually a part of this hydrothermal vent system that was later mined for its metal ore content, but also some of these caves and cavities are still filled with water. For example, here is the location of the Osiris shaft system connected into this subsurface causeway industrial infrastructure system. Well, it may actually be sitting on top of one of these water-filled subterranean cavities that maintains the consistent water level inside of the Osiris shaft system to this day. And coming up soon, I will present yet another series of chemical analysis data that reveals the TDS, total dissolved solids, of the water inside the Osiris shaft. And I can tell you now, it is not fresh water. And I'll put in some footage now from my most recent tour exploring the depths of the Osiris shaft chamber system. I hope you enjoy.
In the lowest portion of the chamber, the underwater section, it was a never before opened sarcophagus of Osiris.
when they lifted the lid of this subterranean underwater container, they found it empty. So these A-frames and pulley systems are part of the modern archaeological excavation where they were using this to remove stuff. So what was taken out of these chambers, not 100% sure, but that's what this infrastructure is for. Okay, so now that we're all down here, several things to unpack about the construction itself. Okay, so again, we're in excavated bedrock below the Giza plateau. We talked about the veins of iron oxide running from the core of the pyramid, distributed across the plateau. And if you look, do you have the flashlight? If you look into these housings, you'll notice that there are veins of iron oxide running through these housings. And look at this thing. I mean, it looks like it could have been a bar of iron.
It's in a bar.
So again, no mercury was ever found in any of these deposits, but there's all of the other metals that you could possibly imagine.
Right.
So remember from our previous discussions that when the dielectric capacity of a material is exceeded, it spontaneously becomes a conductor. So let's say that that was the function of these iron bars down here inside the Osiris shaft, to distribute the electric field energy that was being received from these lightning strikes down into this chamber. And you'll notice that this bar of iron runs across the housing of each of these chambers. You can see it here. There's a huge, thick deposit here. Another one over here that led into this. This is all a huge deposit of iron that has been removed out of here. So either the electric field via dielectric distribution of electric fields, or if it was spontaneously turning into a conductor because its dielectric capacity had been exceeded. Either way, you're getting electric fields or electric current energy being distributed into this subterranean chamber. You'll see here that there's still some deposits at the top of each one of these. They may look small, but the iron oxide is still inside all of these chambers. Okay? Now you'll notice in this one, this is obviously modern equipment here. Not ancient, but modern. So the black grease that you can see all over this piece is the black grease that you can see here.
Yeah.
There's been some misrepresentation of what this black grease is. This is modern from the archaeological excavations that were down here. Modern axle grease. And there's some very special things about these two containers. So let's take a look over here at this one. This is a material that we have not seen before during our entire expedition. This is a material known as dacite. The closest dacite quarry is at the southern tip of the Sinai Peninsula, which is an extremely far distance to get it all the way here into the subterranean chamber of the Osiris shaft. And I'll turn this off so you can all see that when we look inside of this container, see, each one of you guys can come over here and take a look at the green glow of the material that's down in there. And it's kind of rotate out so everyone can get a chance to look in here real quick. Steve, come take a look. Can you see that? Well, that's the glow of the UV light. Look at the green on the left. Flecks of green. And dacite has an extremely high content of microcrystalline quartz. So we've already been talking about the function of quartz for ultrasound. Again, the finer the particles, the higher concentration of quartz you can get in the material, the more effective it is for producing ultrasonic vibrations. This container is black basalt.
And we'll see that same green material inside of here. If you guys look in here, you can see some green ooze down in there.
I see it.
Okay.
What do you call that?
Dacite.
Dacite.
Correct. Analysis was taken of the surface layer of this container, and they found the external layer of tar, bitumen, or pitch, a petroleum-based compound. Again, modern axle grease coming from this wheel over here, or some of the modern equipment that was used in the archaeological excavations. But they also found a layer of 5 different metals: iron, arsenic, lead, titanium, and zinc. So today, we have an exceptional material known as PZT. What is PZT made out of? Lead, zirconium, and titanium. So they found a very similar metallic chemical composition to PZT coating this container.
What's PCT?
Get to that in just a second. So PZT is a material that we use in modern ultrasonic transducers for the production of ultrasound. Okay? So this material back here, the dacite container, has tons of crystalline quartz. Black basalt does not have crystalline quartz. However, if you coat it with a material that can substitute the quartz content, it can function the same way. So instead of using quartz ultrasonic transducers, you now have a coating material that can also create these ultrasound vibrations.
So you're saying like they coated this because they didn't have any more.
Didn't have the same material, correct? The same chemical and mineral composition of the stone itself. So dacite, again, microcrystalline quartz. So it has an extremely high quartz content.
Okay.
Black basalt does not. But again, if you coat it with PZT, the entire thing becomes an ultrasonic transducer. And we were talking about yesterday during our private special permission into the Great Pyramid, how that container,
In a king chamber.
correct, is like an amplifier for the production of ultrasound vibrations in the chamber. Same thing is true of these chambers down here. And there was most likely one of these containers originally in each one of these housings. They don't know what happened to them. These are the only 2 that are left. But it's believed that all of these housings held a similar container.
Would you say 6 of them or 7?
So it's 1, 2, 3, 4, 5, 6. And the 7th one is actually the shaft leading to the 7th container. So a total of 7 containers within the system.
Okay.
6 on this level, 1
down
on the
there.
subterranean level.
How does the dacite compare to bluestone?
Similar in its
So those burials on the plateau, they're ancient burials or are they more recent?
Well,
Those guys now, okay? I mean, Pharaonic period? Okay. They are, they're from that period?
the Ptolemaic is even post.
Yeah.
Notice the patterns and how they carved it. They carved it like a herringbone pattern.
Yeah. That must be the,
Look how they carved. No, that's gotta be original, because it's on this wall over here too, and over here. They carved it in a herringbone pattern.
oh, Is Petra in Lebanon? So many places to go. So many artifacts.
And they sent a kid down into that shaft, and the Japanese robot, and it still goes further and further and further. They didn't do the full exploration because it's still mud, so after we move all the mud, we come back with a new piece of equipment. You can see how crystal clear the water is.
I'm like hunting megalithic sites, so I have like 16 or 18 sites that I know of, where there are huge different anomalies and huge rocks.
He's been to a lot of places.
That's what I went through.
Can you put the whole thing in? Well, I believe it's probably a very spectacular looking artifact.
And it looks like the top left side is, kind of I wish we could go swimming in there.
Yep. Talk about ancient bacteria.
Yeah, oh, and I see the spider. It's like coming out.
So that one does look like a shell.
Yeah, it's still, I mean,
Huh? Next?
well, hold on.
Are you coming back up?
Yeah, you're gonna have to stand on the ladder and flood it.
Oh, so you can't go all the way down.
Well, you
Oh,
can,
you can.
if you wanna get your shoes wet.
I would recommend not doing that.
Yeah.
I think it might be a piece
Yeah,
of light
it's underwater.
Yeah, I don't wanna get my shoes wet.
It's fine if you
I
set
think
your
it's
back
basically
against the
like
wall
myself.
when you get all the way down.
Okay.
All right, next one.
Shit. That's
Oh, there's
crazy.
lots of water down there.
Just wait till you guys see how big that box is.
Which reminds me of
It's
like
way bigger than this.
an entire outdoor wine.
It's like the size of one of the cut outs. Like the whole entire thing. In manufacturing, when we, at my company, we actually ultrasonically weld things. Yeah, plastics to plastics. And you use ultrasonic beam, and it makes beads like this. It makes beading. It's kind of like welding knives. Like you have a bead line. Bead? Yeah, bead. Okay. Basically an ultrasonic laser. And just
So were these?
moving it through.
So, yeah, I don't know what it's more. But I get the impression that it was, and that's why they were doing such high tolerance. So they popped the lid off and then they put it back on straight. So that I'm certain that they knew the level of the water. And the construction of this thing was planned intentionally, so that they would tap into this subterranean chamber. Now, they also have to be able to pump it out, get this thing down in here, and do all this other work. So that's another entire aspect of the construction process of this chamber, which because we had to use modern pumps to pump all this water out. All right, so now you're in the subterranean third and lowest chamber of the Osiris shaft. And here in the center is the black granite container. And there's a rectangular housing that goes around the container in the center. You can see the lid here has been lifted up and just moved over to the side. So that's why it's off at a diagonal here. In the corner, you can see the remains of the 4 pillars that once surrounded the central container. And if you crouch down and look back here into the northwestern corner, you can see the tunnel that I was discussing in the previous episode regarding the Osiris shaft tunnel system. And you can look and see how crystal clear all this water is. If there wasn't this debris on the surface, I mean, it would just be immaculately clear. So this is an indication of a subterranean water source, an independent aquifer directly below the structure that is not tapped into the Nile, because the water in here does not fluctuate. We know the Nile River isn't anywhere close to this structure now. So the water source underneath this structure is completely independent and enclosed aquifer.
I don't know if I can reach the tunnel.
So back in that corner is the tunnel system that I showed in the previous episode that was excavated by the joint team between the Egyptian Ministry of Antiquities and the Japanese team that sent the robot up there. There's a good shot of the container.
All right, now, I know that this is a lot to process, and we'll have to wait until the official data is released on March 15th before we can assess any of these predictions. But for now, we can have some fun in the realm of speculation. And I know that there are tons of new viewers here that may have a lot of questions. So I highly recommend checking out the various playlists so you can get caught up on my hypothesis that the Egyptian pyramids are a series of chemical manufacturing facilities, including 12 videos with critical chemical analysis data, exclusive site footage presented in this Sunday site visit series, and individual playlists for each structure explaining all of the mechanisms of operation, chemical reactions, and applications for the product. And in the next episode in the series, I have an absolutely monumental breakthrough to reveal regarding the iron oxide and metal or mineral permeated core of the Great Pyramid, and a detailed explanation of how its function was integrated into the operation of the Giza plateau system. So please subscribe and stay tuned. All right, everyone, that is it for today's video. This was Sunday Site Visit 94, Subterranean Components of the Giza Plateau. I really hope you enjoyed today's video, and in the next episode in the series, we will examine the iron oxide permeated bedrock core below the Great Pyramid of Giza and propose a hypothesis for its function. This is an episode you do not want to miss, so if you haven't already, please subscribe to The Land of Chem here on YouTube. Remember to click that little notification bell so you don't miss out on the new episodes that premiere twice per week. Please like, comment, share, and stay tuned. If you want to help support the channel, check out the Land of Chem members only channel and thelandofchem.com, both linked in the video description below. If you want to follow me on Instagram or on X, my handle is @thelandofchem. Ladies and gentlemen, as always, thank you all so much for the support. I think that is it for today's episode, so I will see you next time. Yo, are you still watching this? Please subscribe to the Land of Chem here on YouTube and click that little notification button. New videos coming out every single week. And check out this other episode. Come on, do it. Do it now.